Welcome to Part 2 of the Intro to Statistics, Section 2.1, Percentiles, Normals, Distributions, and Z-Scores. I'm going to go to where we left off and talk about, I'm going to do some clarification and talk a little bit about the different scales that are on this distribution. So we've labeled our mean of 100, and I'm going to go over here and talk up here. This is really more in reference to the markings of where 1 standard deviation goes away from the mean, 2 standard deviations goes from the mean. If we talk about z-scores, which we're going to get into in just a minute, then that's a z-score of -2, -1, 1, and 2. And we can refer to the actual data values that are represented on this distribution. And it said that this was a standard deviation of 15. So this line, when you're talking about the actual data values, represents 100 minus 15 is 85, and 85 minus 15 is 70, and then this is 115, and this is 130. So these are the data values. These are the z-scores are standardized to a mean of 0 and a standard deviation of 1. So we'll get a little bit more into this in just a second. I also wanted to point out an interesting thing. This goes back to our calculus, that the first standard deviation is at the inflection point of the normal distribution or bell curve. So you remember this one, on this side, since it's kind of the ladle dips down, this is going to be second derivative is negative, and it goes to the ladle pointing up, which means that the second derivative is positive. Okay, so all normal distributions are the same. If we measure the units of sigma, standard deviation, about a mean of 0 at the center. Okay, let's talk a little bit about standardizing, and that is in reference to these z-scores. Okay, so we make the bell curve the same as all other normal distributions. Okay, the formula for standardizing is Z, which is the z-score, is equal to x minus the mean, which in this case is going to be mu because we're referring to a population, divided by sigma. And that's given that this distribution is a normal distribution with a mean of mu and a standard deviation of sigma. And x is one of the data points. Okay, so you might be given a data value and a mu and sigma and asked to find the z-value. Or you might be given the mean and the data value and asked you might be given the z and the mean and the x value and be asked to find sigma. So you can rearrange this. You can be given any one of these or any three of the four and be asked to find the fourth. Okay, just as a rule of thumb, when interpreting a z-score, a positive value refers to data above the mean. And a negative value refers to data below the mean. Okay, so let's work a couple of examples. If you had N 64.5, we're back to our women, and a woman is 68 inches tall. What is her standardized height? And so we just set up our equation. Z is equal to x minus mu over sigma. And that would be 68 minus 64.5 over 2.5. And her standardized height is 1.4. And that's positive, meaning that she is above the mean. And in fact, she's 1.4 standard deviations above the mean. So she is above average. All right, what about for a 60-inch woman? So her z-value is 60 minus 64.5 over 2.5, which is a negative 1.0. So she is 1 standard deviation below the mean. So she is below average height. All right, thank you so much for tuning in. I hope you've enjoyed this video.